this one. Probability of getting a king on successive draw from a deck. Y is independent. Y is dependent. If you already draw the king, so reduce. That may affect the chance of another king. Okay? In case if all the king has been drawn, no chance to get, right? The best gambler, they actually make such a chance, dependence case, independence case. What is a chance to win in poker case? Actually, I heard that their strategy is kind of simple, mathematical way. So they try to compute based on the history of the draw. So they try to compute what is the expected value. If that is bigger than certain range, then they bet. Otherwise, they will die. So that is the. But to do that, sometimes not always. Okay. Sometimes depending on the feeling or but that is the kind of. So dependence and independence. So this is the independence. All manufacturers have the identical product. Then it's independence, but American manufacturer love the SUV, European manufacturer don't. Then, which means it may be affected. Okay. Then next one is well known the Bayesian rule. Bayesian rule. So I think that you have seen this equation. Probability of the B given A is a conditional probability. This can be derived from the conditional probability of A given B and times P of B over P of A, which means, so we know the chance of the B, we know the chance of the A, also we know the conditional probability of A given B. Using this information, we can find the probability of B given A. Okay? Even though we do not have the value of this one, we can derive from this. That is the huge benefit of the Bayes rule. So Bayesian rule is based on the conditional probability. Okay? One variable. Using one variable, we can find another one. Okay? That is the big, huge benefit of this. Okay? But at that time, the P, that's okay. So in terms of a Venn diagram, it can be represented as the, for example here, what is the probability of this based on the B, but we do not know such a probability, but we know what is the A, I think what is the B, A, this one. What is the A? Probability of B based on A, but we know the A and the probability of B, probability of A. Okay. At that time, we can say you probably heard about a lot, but this one is the posterior probability, our goal to find, and this one is the prior, our experience, prior the probability, the B, and the A based on the B is called likelihood. Okay? We can compute the likelihood and then so we can test posterior probability. It's kind of the based on the experience we'd like to find the next other probability. So this is the example. So let's see. Mary is getting the married tomorrow at an outdoor ceremony in the desert. In recent year, he has reigned only 5 days each year. So 5 days, okay, each year. So you can see the chance of the rain. Okay, so 5 over 365. Okay, it's a given information. Okay, and the weatherman is forecasting rain for tomorrow. When it actually rains, the weatherman has a forecast 90% chance of the rain that time. Okay, so it's A over B. When it rains, in case of the rain, okay, the rain chance is 0.9, 90% of the time. Okay, does it make sense? When it rains, okay, the B is the P of B. B is the variable for rain. Okay, and A is the forecast of rain. Okay, the weatherman has a forecast of rain. So for example, the weatherman forecast the rain, okay, tomorrow. When it actually rains, we don't know whether forecast is true or not, but 90% are really true. That is this P over A, the given E. Okay, among the rain, really rain day, what is the probability of the correct? Okay, so that is 0.9. Okay, then when it doesn't rain, he has a forecast rain 10% of the time. So not rain, okay? In case of not rain, the forecast of 0.1, so 10%. What is the probability? It will rain on the day Mary's wedding. Okay? So how can we represent what is the probability? It will rain on the day of the Mary's wedding. It's a forecast. What? Rain. That is A. Given A. What is the chance of rain? So B bar A. Probability of B given A. We don't know that value. However, using this one, B over A can be derived from A over B. We know the A over B, A bar B, okay, it's 90%. And also, we know the chance of the rain and chance of forecast, right? That is this, and that is the P of A. That's the 90%, right? That's it. So we can calculate. So that is a P bar A. So given A, so that one. So that is 11.1%. That is the power of the Bayesian. Even though we do not know that value, posterior probability, we can derive the posterior probability using likelihood and the experience. So, and that is the 11 point. It's not like the 10% or 90%. Okay? Because weatherman is not always correct. It's 90%. Okay? That affects the value. Okay, so that's the base rule, and that is used a lot in our prediction nowadays. The given condition, the experience, and what training data, we can guess such a missing value. Okay. The next, the linear algebra. So linear algebra. So if we can find the feature, okay, then if we can find the function. So maximize the energy or the something core function, object function. So then we can reduce, if we can find some covariance related the attribute, we can reduce the dimension. Then finally, so we can find the optimize the function. So that is the goal of the linear algebra. Okay. At that time we can represent such a the data object as a vector. Okay, this vector consists of the four attributes: electron, the Marshall status, the taxonomic income, and chip. Okay, so this is the vector, and then if we have a number of vectors, it can be represented by the matrix. It's two-dimensional data. And like this one. So vector can be understood as the point in the space, multi-dimensional space, like this. The two feature, two attributes, or two dimension. It can be two-dimensional Gaussian space, or the three-dimension, sometimes hyperspace. So 4-dimension, 5th dimension, we cannot imagine, but there might be. So that is called the hyperspace. So I don't have to explain such a vector arithmetic, so you already know something. And as a matrix, so we can represent the n-dimensional data and n number of the data vector. So using n by m matrix also. So matrix has been used a lot. So you have seen part of that. When you product the matrix, the number of the column should be same as number of rows. Then we can, there are 2 by 2. We can have the result is the 2 by 2 for the product. And this is the arithmetic. Obviously, in the matrix, we cannot commutate it for the matrix. Okay? And this should be same. This the A, B, and B, A transpose. Because transpose we can find, yes. So we can compute. Okay, so that is the overview of the mathematics that you'd better know throughout the semester. Okay, I'm not teaching the mathematics; it's just a quick review. Okay, so it's totally up to you how much you guys are studying, especially for the PhD student and the master student who are pursuing the thesis. So definitely you'd better the familiar with such a mathematical notation and formal way to describe your problem and solve the problem. Okay, so if you are familiar with the mathematical notation and mathematical proof and mathematical definition, so much easier to write your technical paper. Okay. So actually, I expect the full day for this one with some couple of quiz, because of the missing day the last week. So I quickly review this, and after 10 minutes break, I will continue the chapter 2 that we didn't cover the last class. Okay.